Okay, so next another clicker question, this time on the composition of functions. If f of x is 2x plus 3 and g of x is minus 4x plus 2, which of the following is the composition of those two? And let's not worry about the derivative yet. So I'll let you work on that for a second. Okay, I assume you're done and you've committed to an A, B, C, or D answer. So the correct answer here is the first one. How do we get that? Well, whenever you have a composition f of g of x, you plug the g of x expression in for x, which means h of x is equal to, and now I take the 2 plus 3, and what do I put in the brackets here? I put g of x, which is precisely minus 4x plus 2. So I have to multiply things out here. I get minus 8x plus 4 plus 3, which is, as shown in the answer, minus 8x plus 7. Okay. Now, I didn't use the notation here, but often you'll see the notation written like this. H of x equal f, empty circle, g of f. And that's indicating a composition of the functions so that I can write that, or I could write it this way. Both of those mean the composition. Okay, so what is the derivative of h? And here we have another clicker question, so I'll pause, let you think about it. Okay, we're back. So the correct answer here, so although this one here is tempting, in the same way we thought the product rule could be written down in a simple form just like the addition rule, this is not the correct one. The correct one is the last one here, where I take the derivative of the outer function, f prime, and plug the inner function into it, g of x, and then multiply that by the derivative of the inner function. When I say inner function, I mean the one that's being plugged into the other function. Okay, so that's the correct form for the chain rule, which gives you the derivative of a composition of functions. So why is this useful? I mean, you can always calculate a problem like this explicitly. So if you have, let's say, h of x equal x cubed minus 2x plus 1 to the 6th power, you can multiply those out, all 6 of those out, and see what polynomial you get. That'll take you a long time. So we use the composition of functions as a really convenient shortcut. So I'll leave you for a few seconds to think about this one. So what do we do here? Well, h of x is a composition, so we have to figure out what the pieces are. So I'm going to change color here. So h of x, I'm going to write this as an outer function, something to the 6th power, with an inner function, g of x, inside it. And so I'm going to say that g of x is this thing inside the blah to the 6th. So that's x cubed minus 2x plus 1. And the outer function, f of x, which I don't actually see the f of x, I see f with g of x plugged into it, but I'm using x as just a placeholder, so x to the 6th. And if you do the composition, you'll see that you take this expression here and dump it in to the x position there. And so if I'm going to calculate the derivative, h prime of x is equal to derivative of the outer function with g of x plugged in, and then multiplied by g prime of x. So f prime of x is 6x to the 5th. That's the power rule. And in the brackets, I plug in x cubed minus 2x plus 1, which is g of x. But now I have to multiply the derivative of g. Derivative of g is 3x squared minus 2. Again, both of those are by the power rule. So which of these do we have over here? We have, here's a 6g of x to the 5th, and 3x to the 2. So it's this one here. Okay. So this I don't usually go through in class, but I'll post these slides with these in here so you can see. This is analogous to the rectangle example for the product rule, but it's a little bit stickier to go through. So I'm not going to talk all the way through this, but you can think about it later when you're looking over the slides or over this movie. Okay, so summary rules for differentiation. We have the addition rule. We have the addition rule here, which says that if f is a sum of two functions, then its derivative is just the derivative, the sum of the derivatives of those two. Product rule is a little bit more subtle. You have to take, to get the derivative of f, you have to take the derivative of the first multiplied by the second, plus the first one multiplied by the derivative of the second. For the chain rule, it's also a little bit more complicated. If f is the composition of g with h, then we take the derivative of the outer function g and plug h into it, and then multiply by the derivative of the inner function.
For the quotient rule, we have a function f of x that's given by a ratio of functions g of x over h of x, and that can be rewritten as g of x multiplied by h of x to the minus 1 power. And when it's written that way, you should be able to see, and I'll go through this in a few minutes, that you can use the product rule combined with the chain rule to figure out what the formula is for derivatives of this form. For now, I'll just write it down, and that is
f prime of x equal g of x g prime of x h of x minus g of x h prime of x, all divided by h of x all squared. Okay, so let's go through a clicker question on that one. So I'll let you read through this question and think about it for a few minutes, and I'll wait for you to come back. Okay, assume you're done. So what is f prime of 2? So we have to refer back to quotient rule formula. And so if you do that, you'll get minus 13 as your answer here. And so let's just go through that. So if f of x is g of x over k of x, f prime of x is going to be g prime of x times k of x minus g of x times k prime of x. And now I have to take that whole expression and divide by k of x squared. So now I got to plug in the pieces. F prime of 2, in this case, is going to be, and here I'm going to need all the pieces again as I did for the product rule. G prime is 2 times k at 2 is 1 minus g at 2 is 3 times k prime is 5, and I divide through by k squared, which in this case is 1. So here I have 2 minus 15 is minus 13 divided by 1 is just minus 13. That's where we got a from. Okay, so that's a refresher on your differentiation rules: addition rule, product rule, quotient rule, and chain rule. So I will put together another screencast soon and post it for you on the next topic, which I think will cover more things about tangent lines.